In the name of Almighty Allah, most gracious, most merciful. Assalamu alaikum. Good day, everyone. I am Jubair al Berune, bearing matric ID ET183027, and I had the privilege of serving as the project lead for our project of prototype communication CubeSat. My role preliminary involves coordinating the various aspects of our project from its conception to its implementation.
Assalamu alaikum. I am Forhadul, bearing metric ID 813020. In this project, I was responsible for the technical aspect, particularly for the ground station implementation of our CubeSat. Today, we are honored to present our project on developing a prototype of CubeSat and ground station for continuous data relay all around the world, which has been supervised by Assistant Professor Muhammad Abdul Qadir of the Department of Electrical and Electronic Engineering of the International Islamic University, Chittagong. Okay. Here is the outline of our presentation. We will begin with an introduction to our project, followed by a review of relevant literature, our project objectives, component use, methodology, equipment setup, result analysis, cost, advantage, limitation, conclusion, feature works, and references. Next slide. Okay. Let's begin with some initial insight into our project. Our project revolves around the development of a prototype satellite and a ground station for continuous data relay. Currently, the field of satellite technology is dominated by conventional large-scale satellites, which are not only expensive to develop and launch, but also have lengthy development timelines. Our aim was to break down the barriers and introduce a cost-effective and efficient system into space technology. Here, here, let's take a moment to review some relevant literature. Here, our project builds upon the pioneering work of experts like Quick Swari Turner, who developed the standard tip satellite in 1999. We also draw inspiration from researchers such as Nagen Munakata et al., who explored variation in CubeSat size and configuration, and studied by Silva KSC emphasized the increasing significance of CubeSat in scientific investigation, including climate monitoring and Earth imaging. Okay, our main objective is to design and develop a prototype of fixed satellite and ground station, and then creating an innovative data transmission interface and establishing a remote system. Next slide. Okay. Here we see the component we use in our ground station. Here we use Arduino Nano, LoRa transceiver, SD card module, SAS controller, battery module, Bluetooth module, and GPS module. Okay. Excellent. Here we can see the component we used to build our satellite. Here we also use Arduino Nano, and we use various sensors like current sensor, voltage sensor, amplifiers, RM module, and solar panel, etc. Okay, here we are presenting the methodology of our ground station. Here we see the block diagram of ground station, where we see an Arduino Nano at the heart of the ground station we developed, which is equipped with various components such as LoRa transceiver, GPS module, clock module, SD module, and Bluetooth module. Then the next figure shows us the block diagram of monitoring and power distribution unit. Here we see another Arduino Nano microcontroller at the heart of the unit, which is equipped with the power source, various sensors and modules such as solar panel, voltage sensor, current sensor, pressure sensor, temperature sensor, and RF transmit module. Next slide. Okay. Here we see the block diagram of our transponder unit, where in receiving port, a LoRa module is connected to the microcontroller, which works as a receiver, and a low noise amplifier along with the SD card module connected to this microcontroller. And in the transmitting part, another LoRa module is connected to the microcontroller, working as transmitter, and a RF power amplifier is connected in this in this microcontroller too. Lastly, the both microcontroller is connected to each other through UART communication. Right now, I would like to hand over the rest topic to my partner. Continue.
Thank you, Forhadul, for handing over the presentation to me. Now I will talk about the circuit diagram of our project. Here's the circuit diagram of our ground station where we see how those modules that I mentioned before are connected to the Arduino and power source. And this is the circuit diagram of our monitoring and power distribution part of our cube satellite, where we will see all the components of the monitoring and power distribution are connected to the microcontroller and the power source. And in the next circuit diagram, we'll see how all the components of the transponder unit are connected to the dedicated microcontroller and power sources. Here, the monitoring unit flowchart begins with the library initialization and checks the sensor data from voltage, current, pressure, and temperature sensor. It's then conditionally transmits available data or enters a delay state. The system continuously loops back to initializing library, ensuring repeated data collection and transmission. The receiving unit's flowchart initiates library initialization for LoRa and SD card module, then check for incoming data. If data is available, it stores it on the SD card and sends it to the sending unit via M2M communication. This process continues to receive and forward data to the sending unit in the continuous loop. The sending unit flowchart begins with library initialization, establishing serial communication with the receiving unit, and load up for data transmission. It waits for data for receiving unit and continuously read and transmit data once available, ensuring an ongoing process. The ground station flowchart starts with the initialization, check SD card status, and enter a main loop. In this loop, it checks for serial data, collects clock and GPS data, send message, and wait for LoRa data. It can store or process LoRa data and check LoRa status for message transmission or termination. Setup process. Here the figure shows the build power distribution unit and monitoring unit. And here we see the build of receiving unit and sending unit, and lastly we see the full overview of our whole system where we see the prototype of our cube satellite and two ground station. Results and analysis. Here we see the available ground station through device, and the ground station is connecting with the device. Then here we see user 1 and user 2 is communicating with each other, so both ground station, and here we see the monitored data from various sensors. Let's talk about some financial aspects of our project. We conduct a cost analysis, and the total cost of our ground station amounted to the BDT of 5,900. The CubeSat prototype cost about BDT 11,045. Advantage and advantage. In advantage part, we see our project offer a less costly data relay system compared to conventional satellite. It also reduces the development and launch time, making it accessible to a wider range of users for applications such as scientific research and Earth observation. Limitation. While our project has many advantages, we also need to consider factors like size, weight, and orbital limitation. Also, the initial cost may be a concern for some. Conclusion. In conclusion, our project addresses the budget constraint of conventional satellite systems, offering cost-saving, time efficiency, and improved collaboration. It has the potential to enhance global communication network, particularly in remote areas. Future works. There are immense potential for our improvement and expansion in future, such as integrating machine learning algorithms, exploring commercial application, and deploying CubeSat constellation for redundancy. Thank you for joining us on this journey through our CubeSat and Ground Station project. Now we will demonstrate our project practically.